watching from home, the link to the problems is in your Unit 1 module. It's called In-Class Practice Hardy-Weinberg or something. So you can go find the problems because you're not going to see them if you're at home. Okay, so here we go. If you need your notes, get them out because, you need to know what p squared is and 2pq and q squared and all that stuff is. And if you need a formula sheet, you can get that out. If you're watching from home, your formula sheet's in your resource module if you need that. Okay. All right, so first of all, we are going to just work a simple problem that just kind of starts us where we need to begin normally, except then, of course, College Board amps it up a little bit, but we'll amp it up in a minute. So this is from Captain Marvel. So in a population of squirrels, the inability to shapeshift is a recessive trait. On Scrollos, there are that many scrolls, 1,406 something, and 4,612 are unable to shapeshift. So what would be the expected frequency of the heterozygous scrolls if the planet's population is in Hardy-Weinberg? So first of all, there's your cue. You want to wait, or you want to be sure that they're wanting you to do a Hardy-Weinberg before you ever begin. Okay, so they did definitely tell you that's what you want to do. And then you have to figure out where to start. So where do you start? And what is the beginning? What is the first one that I can get always? Q squared, because those are individuals. So I want to start with Q squared. And if you don't remember, that is like the recessive individuals over your total population, okay? So that's where you begin. If you don't know, if you didn't know where to begin, write this in your notes or something. So start here, if you can. Now, sometimes you're going to have to, deal with whatever you've been given. So in this instance, unable to shapeshift is recessive. So, oh my gosh, my marker's being a toot. Okay, so then I should be able to get my frequency, my Q squared, right? I just put my recessives over my total, and I should be able to get my frequency. I usually round to the I usually round to the hundreds in my freshman and then to the thousands with you guys. I honestly am not very good at
significant figures.
Yeah, I'm not very good at enforcing significant figures, so you're welcome.
Well, is all 485?
No, not yet. But they say prepare for it to come, and I think I'll just quit instead of preparing. So. Okay, so that's what I got for Q squared. Is that what you got for Q squared? Yeah. Okay, now what can I find?
Q.
I can find Q. I can find Q because I have Q squared, so I just have to get the square root of Q squared, and that should give me Q. Yeah. I got 179, but is it 178? Probably because I just probably just because I went further than that on my calculator. Okay, so now what can I get? No, wait, before we go any further, what is Q? What did I just find? The frequency of what?
Recessive alleles.
Recessive alleles, right? So how many actual little a's singular are in the population, right? Okay, so now I can find P because what do I know from the formula sheet? P plus Q equals 1. So that means that P must be
0.822.
Okay. And then, what am I trying to get?
Heterozygous.
What? Heterozygous. Do I need to get P squared? No, I don't really need to get P squared. I have 1 minute and 30 seconds to work each problem in my multiple choice section, and that's on average. Some of them will take a lot longer than that, some will be faster. I don't want to do any math I don't have to do. So let's just go ahead and just get 2PQ because that's my heterozygous. I just had an idea that may not work, so we'll see. You can't really see the board in the Google Meet, so I'm going to put a little light on it. We'll put a little up lighting and see if that works. I wish I could turn on like my lights differently, but wishes don't actually come true very often. Let's see if it works. Yeah. Yeah, you can see it better now. Okay, cool. And you can probably see it better now too. Okay, so what is my 2PQ value? I can't hear you. What?
295.
Oh my gosh. Is that what you guys got?
I got 293.
Uh-oh. That's okay, probably because of how you did your calculator. Sometimes you round like terminally, they're different. Okay, so any questions about that? So that's pretty scaffolded for you, right? I was like, okay, what do we do first? What do we do second? What do we do third? So hopefully you got it. Yes. So I just literally take 2 times P times Q, and then I get my number. Is that like on my calculator? 2 times 0.822 times 0.178. There's little squares in the marker bucket if you need it. Okay, so questions?
Oh, thank you.
Yes, Sam.
How did you get P?
How do I get P? Okay, because on the formula sheet it says P plus Q equals 1. So, and really that makes sense because this is my recessive allele and this is my dominant allele. So if I know my frequency of my recessive, the rest of them have to be, out of 100%, the rest of them have to be P. So yeah, that's how I got that. So I just subtracted 1 minus Q. Any other questions? Because I'm going to try to take off your training wheels as we go, not work them with you so much and make you do it. So like, ask your questions now. I'll leave you a question.
Yeah, so do you not want to round on Q and P for the answer? Because I rounded and got different.
Honestly, whenever you're dealing with thousands of places, it doesn't make, it actually does make a considerable difference if you're looking at numbers of individuals. Like we'll figure that out here in a little bit. But they don't care that much on the AP Bio test. Now, if they start making us do significant figures, we'll have to do it their way. But so far, we haven't said they haven't gotten to that yet. These are often multiple choice, like almost always multiple choice questions. So you just, you pick the one that's closest. And they're not going to be like, oh, if they round to 1,000, we'll put that answer on there. If they round to 100, we'll put that one on there. Like they don't do that. They do more like, we'll put the answer for Q, the answer for P, which they know which variable to use, things like that, okay? All right, so then they sampled the squirrel's DNA if they have any. It was found that 98,655 squirrels are actually heterozygous. So then you're supposed to say, does my number match this number? How can I figure that out? How can I determine if I have 98,000, if I've got a frequency here? How do I make this? Yeah. Yes, so I can either, I have 2 ways to do it. I can multiply this by the total and get a number of squirrels, which they gave us in the problem, or I can take what they gave me and divide it by the total and see if I get my same frequency. So either way should be very similar, okay? So, and what we're looking for is, this is the part where do we reject our Hardy-Weinberg or do we fail to reject our Hardy-Weinberg? Okay, so this is what we got to figure out. Is it the same?
No.
So we're going to reject our Hardy-Weinberg, which means evolution's happening. There's change. It's not equilibrium. Is that what we do for equilibrium, Jack? I forgot the hand signal.
You go to your patent place.
Okay, thank you. Apparently Dorch does this thing. I don't know. Okay, I referred to that in 6th hour and they all went crazy and started clapping their hands. So I was like, okay, Dorch, it's your legacy. All right, so questions about how to do that type of problem? Yes.
So the last number you multiply by the total tested?
Yeah, and it should give you like a number of scrolls and then you see if they're the same. Ish, within about 1%. Is that
That's my question.
That was your question. Yeah, and there's not a rule for that. I don't know why there's not a rule. There should be. But I usually do it about within 1%. Okay? Other questions before we do the next problem? Okay, the next problem is similar. So you can erase your board if you want to. And then the third one is a little bit harder. So I'll walk you through less. I'm going to actually not tell you where to start on this one and see if you can get started. And then I'll help you get it, but why do I keep setting things down? Because my dress doesn't have pockets. Take that. Oh, here it is. Okay. I've been on the Hunger Games kick lately. In the Hunger Games arena, scientists have created tracker jackers, but their ability to reproduce escaped the scientists. The neurotoxin that the tracker jackers release is recessive, and scientists are concerned the entire population will soon be non-neurotoxic, and the games won't be as entertaining to the capital. Scientists are predicting that there are that many tracker jackers in the arena, and a random sampling of jackers showed that 0.58 of the jackers are non-neurotoxic. Oh, it's funny. I switched the slides on the other one, but this one was already presenting, so they didn't switch. This is actually the hardest of the three. If it were N, Hardy-Weinberg would, okay, what would the heterozygous be? Okay, so we need to start here still. But they didn't give us what we need to start. What did they give us? They gave us 0.58 is something. What is it?
Q squared.
No, they didn't give us Q squared because that says non-neurotoxic and it says neurotoxin is recessive.
Oh,
so our Q squared would be the neurotoxic, and this is non. So what did they give us?
B.
Not the allele, yeah. They gave us frequency of what?
The
Dominant phenotype. Which genotypes are dominant phenotype? Which? Yeah, they did us dirty. And they gave us this. Okay, well, so that's basically P squared plus 2PQ is what they gave us. So that was what was given. So what do I have to do? I got to get Q squared. I still have to start with Q squared, right? Because I don't know how many of those are which, right? So how do I do that? I got to subtract it from 1, right? Because the only thing I'm missing is Q squared. And so if I can subtract it from 1, then I'll get my Q squared, which should be 0.42, right?
Yeah.
Okay, there was a problem on your practice worksheet that was totally for your practice, so you didn't have to do it. That did this. And I got the most emails from that problem. People that are trying to do some practice, and they're like, I don't know how to do number 4. Like, what? Number 4 is always wrong. I don't know what's going on. Because it told you the dominant phenotypes, which are individuals, but it's both homozygous and homozygous dominant and heterozygous. So you can't separate them. So you have to take that number, subtract it from 1 to get your Q squared, and then you can begin. Okay? Yeah.
Subtract it from 1. Isn't that just Q?
Q squared.
Okay.
Right? Because the only thing I'm missing here is Q squared.
Oh, yeah.
I'm not missing Q, I'm missing Q squared.
Yeah.
Right? Okay? Still got some confused eyebrows. Tell me, speak your confusion so I can help you with it. Or just think about it for a while until you get it. Yeah, what?
So, how is it? I can just add that to it.
So so they gave us this, right? And so the only thing we're missing is Q squared, right? So if I did on my formula sheet, right? So these 3 should equal 1. Q squared plus 2PQ plus Q squared should equal 1.
Oh,
And the only thing we're missing is that. So they gave us those 2 equal 1.58, so I have to figure out 1 minus those 2 should be 1. Right? Okay. Anybody else? So I can help you with your brain? I'm not a brain doctor. Okay, so then take that and find your variables. And I'm going to walk around because I have the answers right here in my hands, and I will see how you are doing, and you can ask me questions individually or whatever you need to do. This is what we're doing right now. Good. How do I find which one? Right now I've got my you got Q squared. Or you understand that? How we got that?
yeah.
Okay, so now you go to Q. We gotta go to Q first. So we have to find the square root of 0.42. somebody for Q alone. And you can find P. One minus. And now you can find it. What are we looking for? Heterozygous 2PQ. So all we need is 2 times P times Q. And then you should have your frequency. Did you get it? 0.456, that's what I'm looking for. You got 0.456 for your 2PQ, you're good. Alex, how we doing? Did you do this one? You got it. Okay, work on the next one because this one we're pretty much done with. So make sure you start on the next one. Okay, what are we doing? Okay, P plus Q equals 1. So if you just take 1 minus Q. Which means they're down this much. So minus 1 minus that. Okay, are you doing okay? You're doing okay? Yeah. How are we doing? Yep. You do the rest of them, like, please, 35. Yep.
Is there any more?
Yeah, that'll be like how many numbers. So you have.
Yeah.
She never got in there.
2 times P times Q.
Oh, yeah.
Oh, additional. She gives it.
Yes, you use, yeah. 2 times P. Like all in a row. Okay, so then it's going to ask you how many, the number.
Yeah.
So to get the number of heterozygous, you take that, you take your frequency you got multiplied by the total. Yeah, frequency you got multiplied by the total. So it should say something else down here, maybe. Maybe. Why is this not working? Why is my life not working? There we go. They extrapolated 218,170 were heterozygous, and they wonder if they should be concerned. Is evolution occurring, kind of thing. So take your frequency you got, your 0.456, and multiply it times the total. 0.456? Yeah.
It should be like 2180. 2,118.
Okay, so that's within 1%, right? So they're holding. So they're not evolving in that way. Now they might be evolving in other ways, but not in their neurotoxic. There's no reproductive change in neurotoxic. Okay. Cool. Questions? Yes. The goal today is just to become more comfortable. I'm not expecting you to be Hardy-Weinberg masters by the end of the hour, but
So
we need more comfortable. Yeah.
just with the 218,000, multiply that by.
Multiply the total by this and see if it equals 218. The total is up there, 478. Yeah.
You have to write it for an
Oh, yeah. Either you run it the wrong way or you run it internally. You know where you let it go.
And then
like,
you compare it
square
to
that.
what they want.
Or stuff like that. Like sometimes like when I do
Okay.
this, okay. Well, yeah, and rounding errors like that. Okay. One more practice together, and then we will, and then I'm going to tell you how to get to your College Board questions. Okay. Life finds a way. Oh, this is why Jurassic Park's been stuck in my head all day. Okay, all day. Like it's been a long day. It's like literally 9 o'clock. Okay, in Jurassic Park, We have some velociraptors. First of all, they're trying to get the velociraptors tested for lysine contingency, which that alone sounds frightening. That allows them to control the population. So the lysine contingency is dominant. So the first thing I would do is try to figure out what they're giving you. So lysine contingency is dominant, but scientists are concerned the recessive is increasing and will soon overtake lysine deficient dinosaurs. They figure out the population has 326 velociraptors that are lysine contingent. Is that dominant? Yes. So on my little thing, I'd be like, okay, so that, so what did that means that the big A plus is going to equal how many? 326. And the little a is 87. Okay. So at least first know what you're dealing with. Like write it down and be like, okay, this is what they're telling me. And then so you need a total. There you go, total. Okay, so in order to start with your Q squared, you have to have a total. You have to have your recessives over total. So make sure you have both of those numbers so that you can get started on this one. And after that, this one should go pretty quickly if you're starting to get the hang of it, because it's pretty straightforward after that. Can you see it? So little a is 87. That was good. So then get right here. Do that. Start there. P squared. P squared. Well, you did P squared. And then 2p2 is 0.5. Yeah, you're good. Yeah, so your 2pq should be somewhere around 0.5, could be 0.498 or something. And then your p squared should be somewhere around 0.29. Yeah, that's what's nice. I just rounded. Okay. So how are we gonna? Okay. So for p, actually, I use this one, right? And so once I have p, and then I go down. Yeah. Yes. You get the sort of you get and then the blue on the bottom. So basically it's 1 minus so you plug a unit and then you get 1 minus so I was like, I came in for help. You got that. Okay, so then from there you have to make a Q from that.
Actually, yeah.
So because you can't go straight to that because that's squared plus. So because it's all
Oh,
so you have to go 0.21, get the square root of that to get Q. So
which is like
oh, you didn't get plus square.
so
Then P is 1 minus. Okay, what's up?
So you said that these first was 2 files.
P squared is around 2.9. Yeah.
Around what?
2.9.
0.29.
0.29. Okay, so you've got, it may be just, okay, so this I got 0.21. So we're already off right there. 87 divided by 413. Oh, no, you divided by your dominance. You gotta add them together, get the total. Oh, those tricky buggers. What? Are we what? I don't know. Let me see. Let's see what's next.
I want to pick up my book. So I'm going to for you.
Thank you. Teacher manual. I never had one of these before. You guys are in trouble. Now I have all the answers. This is my AP teacher manual. Okay. Let's see what they actually want us to do with this. So they're saying 187 are homozygous dominant. So which variable is homozygous dominant? P squared. So they're saying 187 should match your P squared frequency. So does it?
I got one line.
Okay, so no, doesn't, because 1% of that would be like less than 2 dinosaurs, I think. Wait, no, yeah,
121.
Yeah, so they are having a little bit of, and so you said you expected fewer homozygous dominant, 121?
Yeah.
So actually, they may be evolving the right way for them towards the dominant, so whatever. Okay. Yes, Sam. No? Yeah.
How do you find the thing we just did?
That number? Okay, so then I said, it says homozygous dominant, so I know that's p squared. So I find my frequency for p squared and I multiply it times my total, which was 413 in this instance. And that should give me how many I expected them to be. Any other questions? Okay. Whew. All right, here's what I want you to do now. I want you to get in, you can leave your workspace out because you're probably gonna need it. But get into your Chromebooks in your My AP classroom. There's 4 questions I want you to work. And today I am gonna start with number 4 because it's the hardest one and I wanna give you a lot of help. And the rest of them you should be able to do on your own, okay? So if you have not yet got your account with My AP Classroom, the codes for that are in the top of your resource module. It tells you how to log in, where to find it, the link, and all that stuff. So go there, and then I'm going to show you how to do number 4, and then we'll go from there. See? It's missing Jurassic Park all day long. People are going to be sick of it. You already are. Where's my AP classroom? Here it is. So when you get there, by the way, they've redesigned the AP Classroom. If you haven't played with it yet and you did last year, you're gonna be like, what the heck? There should be a quiz, Hardy-Weinberg practice assigned to you somewhere in there. And only 21 of you have logged into accounts, so I know that we're a few short. So some of you guys are gonna have to get your code and log in today, so make sure you do that. And then you should be able to click on your Hardy-Weinberg practice quiz, and you should see that there's 4 questions. And we are going to start with number 4, okay? And then you can do 1, 2, and 3 on your own because they are pretty much like we were doing, though you're going to have to think. So I would have to say that one thing you're going to have to get used to do these quickly, which is kind of yes, doing them, we need you to do them. But if I want you to get points for them on the test, I need you to be able to do them quickly. Otherwise, just skip them because it's good to know your weaknesses. And if you know that Hardy-Weinberg is going to take you a solid 5 minutes to do, not worth it. Or save it to last. So in order for me to be confident that you can get the points on it, I need you to be able to do it quickly, okay? And one way to improve your speed is to improve your vocabulary. Like when it says homozygous dominant, when it says the dominant phenotype, when it says all like what are they talking about? Like that's the best way to improve your speed on these because then when you read it, you don't have to sit there and consider and try to figure out and just waste your time. You'll already kind of know. So one of the questions that's number 4 on your practice, your Hardy-Weinberg practice, you don't have to do the Hardy-Weinberg practice at home. Like there's just a little worksheet in there, little self-grading worksheet that you can do if you want more practice. And it tells you if you got the answers right or wrong, tells you which one you missed, blah, blah, blah. But the one in there, it says the dominant phenotype frequency is this. Well, if you don't know what dominant phenotype is, then you're going to have a lot of trouble answering that question right. So that's kind of what I'm saying. Like you've got to get those words down. And those are very much genetics words. And so phenotype just means physical expression. So if it's the dominant phenotype, that's your homozygous dominant and your heterozygous together. Okay, that's all of your dominant expressions. Okay, so that's the kind of thing you have to be able to do. Did I have a hand up back here somewhere? Once you get there, go to number 4. Once you get to your Hardy-Weinberg thing, go to number 4 and just read it. And just kind of start to think how would I even begin this problem? And we'll see if you can come up with anything else. You kind of start playing with it, try to figure out what your expected values would be, how would you go that way, and then I'll show you what you actually have to do to solve it. Maybe you hit on it, maybe. Hopefully you're close enough that I can get started without your brain freaking out. Are you still having trouble logging in?
It's telling me like it sent me my username,
Uh-huh.
but it says it's wrong.
It says your password is wrong?
No, it says my username.
It says your username is wrong. I may be able to find your username. And while you're waiting, since we're having a little login issue, if you want to work on question 1 or 2 or 3 or whatever, because those are more, if you're like, I have no idea, then feel free. Oh. You got it?
Yeah.
Your student ID? So you're trying to create an account?
No, it says like I made an account.
Uh-huh.
And then when I put in the code, it says register. I have an account. It's just should I put my like ID number, like my school name?
I don't know. Do you guys know? I've never had to do that, so I'm kind of confused. Let me see what it says here. So why is it asking for information if you already have an account?
Yeah, it says student information to my school.
Well,
grade level.
just skip that for now. Can you?
Yeah, I think.
Yeah. And yeah, because I don't have you in here. Anybody else not in an AP account? Did you find your codes and everything you need to get in? Because I have quite a few. I'm looking through and I'm like, I don't see you. I don't see you. Okay. All right, so let's start with number 4 here and just see what we got. Okay, let me bring back to where I was. There I am. So clearly these are observed. And I know that because, first of all, these are the ones that they counted, and that's how you observe things. And also because it nicely says number observed above it. So if it didn't say number observed, I still know that when I'm doing a chi-square, when I count things, that's my observed, right? Okay, so there's a lot of different ways that I played with this to get it, but let's just cut to the chase. You end up having to know how many alleles you have in the population. So basically, in order to calculate my expected, I first have to know how many dominant alleles I have and how many recessive alleles I have, okay? And I can't calculate that with Hardy-Weinberg because that's theoretical, and I want observed, right? I need actual how many alleles did I observe in this population. So now it's just really simple. You just count how many alleles you have here. So if I have 75 homozygous dominant lizards, and by the way, you should know how to do this particular skill I'm doing right now because this does crop up on the test when you're not supposed to do Hardy-Weinberg, but instead you're supposed to count alleles. So make sure you can do this. If I have homozygous dominant lizards and I have 75 of them, how many dominant alleles are included in that little population right there? 150, right? Because each of my lizards has 2 of the dominant allele, right? And how many then are here with my little heterozygous? 15, right? So that gives me a total of 165 of the dominant allele, right? Does everyone see how I got that? Because each of my 75 lizards has 2 here, and then those 15 have 1. So I just multiply that by 2 and then add those 15 in. So far, so good? Okay, how about my recessives? I have 15 in my heterozygous population. How many do I have here? 20. I have 20 here because I have 10 lizards and each of them have 2 recessives. So that's 20 plus that is 35 total alleles, right? I'm sorry, recessive alleles. 35 recessive alleles. So far, so good? How many total alleles do I have? Should have 200 because I have 100 lizards, right? So each lizard should have 2. Okay. It's like, we're just beginning. Like if I'm sitting here counting on the clock, right? 1 minute and 30 seconds to do this. Yeah, right. Okay, so 200 alleles possible, and 165 of them are dominant. What is my value for P in Hardy-Weinberg world? 0.825. How'd you get that, Jack? Yep, I just took my frequency of dominant alleles, which is 165 dominant alleles divided by my total. Should give me 0.825. Are you with me so far? Seeing nodding, good. Just gotta make sure I'm not losing anybody. I'm going kind of fast. Okay, and then what about my value for Q? I'm gonna have to take my 35, and then what'd you say it was? 0.175. All right, now I have a place I can start. Sort of. Oh, sorry, people at home, you can't see that at all. Twist. Okay, so now I have a place I can sort of start. All right, now I know my observed alleles, right? Now I need to find my expected genotypes using the alleles that I observed. This is almost like counting up fruit flies. Now that I know how many fruit flies I have, now I have to figure out what my expected was, right? But this time we're using the Hardy-Weinberg formula to come up with our expected numbers. Yes?
I thought alleles was the 2 letters.
Alleles are P or Q. Individuals are these over here. So this, is that what you mean by letters? So this one's like P squared, 2PQ, Q squared. These go with these. Is that good? Clarify? Is that what you were asking?
Not really.
Not really?
I don't, why is, what's the difference between where you have the 2 letters and then the single letters?
Okay, so my single letters, I have to take into account that each of these guys here have 2 of the dominant alleles, and then my heterozygous just has 1. And so that's kind of, the heterozygous is kind of the difference between them because it has 1 of each. And so you have to like, so while this tells me how many individuals are in my population, this tells me how many alleles are in my gene pool. Like if I take all the alleles from everybody, that's the difference in there, okay? Okay, so now I just need to use Hardy-Weinberg to calculate what I expected these values to be. So here's my observed values right here. And I'm gonna take off these 2s so it's not confusing. And I need to figure out if these are my observed, so this is my observed for my chi-square. If I had 0.825 of my alleles were dominant and 0.175 of my alleles are recessive, what did I actually expect my genotypes to be? So that's what you have to do now. So basically you just take your p-value and square it, multiply it times 100, which is nice, they give you 100 lizards because then you just move your decimal twice and you're done.
Almost like that was intentional.
Almost like they were trying to help you be faster. I'm like, well, if you wanted to help me be faster, don't give me this monstrous problem on the test. That would help me be faster. Okay, so 0.825, you're going to square that to get p squared. And then just move your decimal twice or multiply it by 100, and that'll give you your expected for this guy right here, homozygous dominant guy. At that point, you could run your chi-square for that guy. You could be like, all right, expected, observed minus expected squared over expected. Now I've got a value for that. And then you do the same thing for your heterozygous one. You figure out what you should have got if you did 2 times P times Q over here. What should have I gotten? Okay, and then you run your observed minus expected squared, and you get a value for that. Okay, I'm gonna do it up here, and I'm gonna kind of clean this up a little bit because it's a little bit of a hot mess. So,
It should be.
and then hopefully, don't say the answer.
Okay.
After you add them all up, you add the 3 up. Don't say the answer, but it should be pretty close to one of the 4 multiple choice options, within reason, because it's not going to be perfect because you didn't round the same way they did. Okay, so let's see. So this is my P. The marker's running out. It's gonna make it hard to see. I'm gonna try to kind of show my work here so that you can kind of follow along.
Do you go until 8 today?
We have 15, I think.
4 minutes.
Is it 20? No. What time do we go to today? At 15, I think.
I think it's 15.
I think it's 15, yeah. So we have a couple more minutes. Okay, so Jack, what'd you get for p squared value?
I got 0.681.
Okay, so that equals 68. for this, right?
Yeah,
So expected is 68 here. Okay, what did you get for 2PQ?
0.031.
So that's 31.
Oh, wait, that's Q squared, I'm sorry.
That's Q squared?
Yeah, 0.289 is, 2PQ, I'm sorry. I did mine out of order.
0.289. Is that what everyone else got?
Yeah.
Yeah.
Basically 30?
Yeah.
No, basically 29.
29.
Okay, and then what did everybody get for Q squared?
0.031.
Which is like 3. Okay, so then you just use these numbers right here to do your observed minus expected squared over expected, and you should do that and then add them up, and you should get one of the multiple choice answers within reason. It's like close. It's not on it, but it's close. It's obviously one of them over the other. Okay? Minute and 30 seconds, think you could go?
No.
So this is probably one of the ones they factored in about 5 minutes for, and then they cut some of the others, made them really short. They do factor in your time that way, but it is hard to like sit there and say, okay, I'm going to spend all the time to get this 1 point, and I don't recommend it. I don't recommend sitting there and going, I'm going to spend all the time to do this 1 point. I recommend doing it last if you have time to try for that point. All the points are equal in the multiple choice, so there's no reason to spend all your time on one problem and lose out on several others because you ran out of time to finish the test, okay? So now what I want you to do, I want you to finish this problem, and you can like take a picture, write it down or whatever. And then I want you to do the other 3 at home, and I want you to read the section for your reading if you haven't yet. You're supposed to read it before tomorrow, okay? And what it is a Hardy-Weinberg like recap, like allele frequencies and all that stuff. It should help you more with the vocab. You should start to feel a little more comfortable with it now that we've done it, okay? There's also practice problems in Canvas that are totally optional. Like I'm not even gonna look and see if you did them wrong. And if you're, that way if you want to practice more, you can. Okay? What questions do you have for me, Annie?